Okay, so we start with the webinar. So today's topic is to do analysis of historical data by using time series analysis, right? So basically, what is a time series analysis? So time series analysis is like, let's say I have a historical data and I want to analyze that historical data for predicting the future. And the best example of time series analysis is a weather forecasting, right? So by using the historical information, right, what I do is I can predict what will be the raining for next 6 days, next 8 days. So I'm analyzing historical data by which is a time related data. Let's say I want to view my Delhi sales. So what I'll do is, if I want to find out which factors are affecting my sales, so I'll take a historical data for last 6 months, last 1 year, right? And I analyze that data for a future predictions. It's always better if you are doing time series. It's always better to have a maximum amount of data, right? You just not have only 1 month data or 2 month data for analysis. So you should have a maximum amount of data, and if it's always good to have a recent data. Okay, so when you are doing time series analysis, these all factors you need to take care about. Okay, so we'll see in a detail what is a time series analysis. So what is our today's agenda is about the time series. What is time series? Objective, characteristics, because in a time series we have a different models to run, like linear regression, like a logistic regression, right? In a time series also we can build a model which is suitable to our data, and in that also we have lots of models in a time series. So we'll choose model accordingly which is suitable for our situation and our data. So we'll see those characteristics, then component of time series. So whenever I run a time series modeling, which factors I need to care about, which factor I can take into account to run time series analysis. And the last one is the methods in time series. So as I told you, what is a time series? Which can say a sequence of measurement of the same variable collected over time. So is that I can say that I am studying one single factor over the period of time. I can say I am studying sales of my company over the period of time. Okay, last year this much sales we have done of our product. This year this much we have done. Last to last year this much we have done, right? So what I'm doing is I'm studying only one factor over the period of time. So I just want to know that how I can improve my sales, product sales, right? And I want to find out which factors are affecting my sales. So what I'm studying is a sales. So when I have a sales over the period, let's say for last 6 years, last 5 years, right? So first what I will do, I plot the data. So when I plot the data, which is specially of time series, I get a trend in that. So this is called the arrow which you can see, it's nothing but the trend. So let's say 1 year it is increasing, the second year again it is decreasing, third year again it is increasing. So nothing but what you are doing is you are studying the pattern of your data, historical data. So when I study the pattern of my historical data, I am able to predict what will happen in the future. Not only by the visual representation of the data, but by applying suitable model to your data. So time series analysis, as I told you, consists of 2 steps. One, building a model. So whichever suitable model is present for my data, I'll build that model, and the model to predict. So most important part, what we're going to do is to predict, right? time series pattern. So as I discussed with you, to run a time series model to your data should be of enough time. Let's say I want to predict sales of my company for next 5 years. So to predict the next 5 years, I can't just take a last 6 months data, which is not enough data, right? So to predict the forecast, to predict the future, you should have enough amount of data which is present with you. And that data should be of consistent type. Means you should not have missing data in between, right? Because if you have missing data in between, what will happen? It will affect your results accordingly, right? So you should not have missing data in between. So your data should be of a consistent type. Okay? Important feature of the time series is a pattern, as I told you, right? We plot the data. So after plotting the data, we get the pattern. Okay? How the past affects the future, or how time series can interact. Means how your data can be interact with your model. To forecast future values of the series, this is what our objective is. This is the use of my time series analysis. I am building a model, but the main aim of my model is to predict the future, right? Measure the quality of a product in some manufacturing situation. So what you are doing, you are measuring the quality of a product in some manufacturing situation. So what you are doing is you are predicting the future, right? What happened? So this is a time series component, series with the trains. So series, so when you plot your data, you get your data like this, which is showing you a train. Means what? Your starting point is like this. Okay, so this is the data which you have from the 2000, right? So it is increasing, again it is a decreasing, again it is a increasing. So when I plot my data, I get such a type of train, I get such a type of visualization, right? This is nothing but I am plotting historical data, right? So this is what observation increases or decreases regularly through time, right? Means what? Throughout the time, it is showing you different kind of behavior, right? Let's say last year in the 2000, my data is increasing, again it is decreasing, again it is increasing. So it's not only same kind of behavior, it is showing you different kind of behavior over the period. This is called the trains. This is the train data, right? Then series with the seasonality. Observations stay high, then drop off, and pattern repeats from one period to the next. Now there are two components when we talk about time series, seasonality and a cycling pattern. So mostly they are same. Okay, but what is different between that is in season, I should know the time gap between them. Let's say right now event A is happening. After that event B will happen. After that event C will happen. Right? So I know the time gap between them. So right now if event A is happening, my next event will be B, and I know when it is going to happen. For example, festivals, right? Festivals come every year, right? And at a certain period of time. Okay? So let's say if I'm into manufacturing, if I'm into the business, and my sales always go high when festivals are coming, right? So this called as a seasonality. Your events are occurring, okay, repetitively with equal interval of time. But in a cycling, it's also repetition, but time period is not mentioned over here, right? Now, after some time or after some years, always recession will come in your business, right? That is the defined thing. That is a definite thing. But I don't know when it will come. It will come after 5 years. It will come after 10 years. It will come after 20 years. I don't know the time period, right? I know recession will come, but I don't know when it will come. So the time gap, I don't know. Like, so in seasonality, I was knowing the time gap. Let's say festivals. When festivals are coming, I know. Every year when Diwali comes, the month of October, November, right? And every year it is going right now, right? Random variation. The events which are very irregular into the nature. For example, earthquake. It's very irregular, right? It will happen, it won't. I don't know. Because time gap is very irregular. This event is very irregular. I don't know whether it is happened or it will not happen. I really don't know, right? So this all kind of data we are getting when we do the time series. We get a data that is showing you a trend. We get a data that is showing you a seasonality, cyclic component, or noise. Means what? Random variation. We don't know when that event will occur. Now, why we go for a time series? What is the importance of time series? First of all, very important to study historical data, to study past behavior, right? Helpful in forecasting. So by studying the past behavior of the data, what I will do is I will forecast that what result will occur in future. I can find out. And as I told you, best example of time series is weather forecasting. How they do this? By studying previously data, and they always compare, right? Let's say if in this June, if we get heavy rains, they always compare with the last year or last 10 years, right? And sometimes you get a news like this is the heaviest rain in the last decade. How they going to find out? They are analyzing historical data only, right? And by analyzing that, they will tell you when and how much rain will happen. And this is just, we can say, they are assuming, they are predicting. So it will not be always 100% sure, right? Weather forecast, you will never get 100% sure, right? Because sometimes they say it will be rain tomorrow, but sometimes it never rains, right? Because it's a predictions. It's not the certain thing. It's not a definite thing, right? It's a predictions. Now, helpful in evaluating the achievements. Let's say the best example I can give of this is, let's say I'm into the management team. Okay, my company is management team, and I want to view performance of every department. Okay, so it's very difficult to have a different sheets for a different performance. So what I can do, if I put my performance in the form of numbers, I will not able to get right. In the, let's say if I'm into the marketing, in the marketing team, right? And if I'm into the marketing team and I'm showing my performance into the form of numbers. Last year we have done this much sale. This year we have done this much sale. Nobody will able to understand and nobody will take interest. But instead of that, if I put that graphically, if I show you trade, right? Last month we have done this much sale. If it is increasing, then it is going down your performance. If it is decreasing, your performance is going upward. So instead of putting your performance into the numbers, if I put into the time series format, if I put into the trade format, everybody can understand that by just looking at your data. And you don't need to think about which number it is showing. You just want to view whether your performance is going upward or going downward. right? And if I'm using visualization, in one single sheet, I can present multiple departments. It's called as dashboard, right? So on one single sheet, what I am doing is I'm presenting multiple departments. I'm presenting multiple dashboards and helpful in a comparison. Now, what is a comparison? I built a model, right? And I'm comparing that model. So what I'm doing is, let's say I built two models on my data. So which model will perform better, I'll decide that with the help of time series. Okay. So these are the methods which we basically use for a time series. The first method we use is called as simple moving average. Now when we use a simple moving average, then my data is showing only one kind of behavior. Means what? Trends are not present in my data. We can take a best example of this is population growth of India. If you plot graphically population growth of India, what you get? Only one line which is going upward year by year, right? So if I'm just getting only one kind of behavior, it's very easy to predict, right? Now it is going upward from last 60 years. What will be the future? It is going to upward only, right? So when you have only one kind of behavior, your data is showing only one kind of behavior, that time we use simple moving average. This is a one method from a time series analysis. Exponential smoothing, and now you have two methods. When your data is showing trends, which is going upward, downward, then it's very difficult to predict what will happen. So in such a case, you have two methods. One is called as exponential smoothing curve and one is called as ARIMA modeling. So when to use which? When my data is showing me seasonality as well as a cyclic pattern, right? That time I will go for exponential smoothing curve. Means what? My data is not showing me steadiness. It is highly trained data. That time I'll go with exponential smoothing curve. My data is showing me trend, but over the period it is very steady. That time we will use ARIMA modeling. Okay, so when your data is having high trend over the period, that time we are using exponential smoothing curve. And when your data is showing you trend, but it is a steady over the period, only waves. So when you have a wave, it's showing you only same kind of behavior, right? Going upward, downward, but those are steady. Those are same kind of behavior. That time we use ARIMA modeling. But when you have high trends and those waves are not steady, that time you use exponential smoothing curve. Moving average, simple, only one kind of behavior. Exponential smoothing. It's very difficult to predict. Which share market chart we can say. They also, some of the people in the share market, they can predict, but it is really very hard to predict how it will, your shares will. Yes. So alpha, so you are having three alpha values. So one alpha is to, you can say, overcome your trend values. One alpha is to flatten your curve. So it's very, very technical. If you go into the, then you will understand what it is showing you. Okay. So when your data is showing you highly trend, I'm not able to understand what will be my forecasting. That time we'll use exponential smoothing curve. And they are not steady if you go through the time, right? Now, ARIMA modeling. ARIMA modeling is also called as a regression modeling as well, auto-regression. So your events are related to each other over the period. This is called as ARIMA modeling. Let's say I am predicting sales of my company, right, over the period. But that sales is a depend on so many factors. That sales is depend on advertising. How much you are doing advertising of your product, your sales will be more. Then marketing. How much money you are investing in your product. So my sales is depend on so many factors, right? But this is just one factor, sales. What I want to predict is sales. So over the period, I am predicting the sales and what will be the future, right? So that kind of situation, I will use ARIMA modeling. Yes. So stationary series and non-stationary series. As I told you, when you have a wave and those waves shows you the steadiness, nothing but in a statistical language we call that stationary waves. So when you have a stationary waves, you go with ARIMA modeling. When you have a non-stationary waves, high pattern, you go with the exponential smoothing curve method. Okay? So stationary series is what? It has no trait. Its variation around its mean have a constant amplitude. Means their amplitude, the difference between the waves are same over the period. Okay? Let's say I can take example of every festivals, your sales go high. Every festivals. And festivals comes at certain point, a certain time period only. Diwali comes in November. My sales go high. Right? Then December, Christmas is coming. My sales again go high. Right? So over the period, my sales is always going high in a festival, which is a certain thing, definite thing, and I know that. But non-stationary wave, suddenly my sales is going high. Sometimes happen, right? Sometimes jackpot. Or if you are using Swiggy, or if you are into the Swiggy, suddenly your sales is going to going high. You don't know why, but it's going high, right? Maybe your marketing is so much good, or you are giving lots of good offers, and so you are getting very good place in competition in the market, right? So that is very trendy. I don't know. And this data, which is a non-stationary wave, it is very difficult to predict. You don't know what will be the future, and you have to trust on your future because this data is very difficult to predict. Okay, so what we do in the ARIMA modeling, first we plot the data to check that whether your data is stationary or not. Then what you do, you calculate ACF and PACF, not PCF but PACF. It's called as autocorrelation and partial autocorrelation. Correlation, relationship between the two factors. It gives you the relationship status between the two factors, right? If you are analyzing last 6 months sales, so it will show you whether your sales is depends on last month as well. Okay, this month I have done 10 lakh sales. Earlier month I have done 9 lakh sales. So that is related with each other. Some factors are really related to each other. This is just nothing but the autocorrelation and the partial autocorrelation. We see the seasonal variation as well. Some other factors are affecting your model. Because of season, it is affecting your model, right? Some other factors we can see. Then we identify PDQ for a non-seasonal series. If we are finding out the autocorrelation, partial autocorrelation, we develop the model, we validate the accuracy, and selecting best model. So this is nothing but we are following regression steps. I'm building a model, then I'm modifying my model based on certain factors, and at the end I will decide which model is the best for my data. It's giving me most accuracy of my data. Industry related examples: production and utilization of gas, natural gas prices, estimation and forecast of the models for the stock market performances of the oil and gas companies. So such a data which show you high trades. Oil sales forecasting using ARIMA model, modeling and forecasting future values for a monthly crude oil exportation operations parameter. So this is the with example of oil and gas industry. Here we can use time series modeling. Okay. Okay, this is the example. Prediction of airline passenger data by using time series. So Jan, year of 1949, these are the number of passengers who has flown by my airline. In 1950, this is the total number of passengers, right? So what is the first step of time series analysis? I'll plot my data. Simple plot, scatter plot. Okay? I'm getting this. So first of all, my data is having trade. And second thing, it is non-stationary. It's not at all stationary because it is not a steady over the time. It is a non-stationary data, right? So what I can do is, I'll decomposition of multiplicative time series. So I'm going to decompose my data. I try to do maximization of my graph. Try to convert my graph into the more specific view. So what it is telling? In the case of decomposed plot, we can again see the trend and seasonality. So when I try to view my graph into the most specific, maximize the trade, then also I am showing the trade, this part. This part. So it's here, you are getting a trade. This is the specified view of your graph, nothing else. So what I've done, I've plotted ARIMA modeling over here, right? And what forecasting you are getting? Same as the ARIMA, right? That's it. So when you plot your data, and not only by looking at the data, but you have to do some test. That test we do to check whether your data is a stationary or non-stationary. Once you see that your data is a stationary or non-stationary, you do modeling kind of thing. In that also again you calculate autocorrelation, partial autocorrelation. Then you build a model. So when you build a model, you take a dependent variable and you take all other as an independent variable. Let's say here I want to know the number of airline passenger. So number of airline passenger will be my dependent variable. So on which factor it is dependent on. Okay. Then what I do, I get an output and I try to modify that output with the help of time series. And at the end, what I do is I predict that. So if I'm using a tool, I get that prediction directly. But it gives you with the help of confidence interval, 80%, 90%. So that gives you the predictions directly. So this is the beauty of tool. Let's say if I'm using our tool, I'll get my predictions directly. After running the model, whichever is the suitable for my data, I get my predictions directly. So it is giving you into the interval. It will give you the point specific also, and it will give you into the interval. Okay?
Now which tools are used to predict the probability?
We use R, we use SAS, Python is there. Yeah, so these three tools are mostly usable. Okay, in SAS, yeah, but it's called as a tool. It's developed on a language, but it's called as a tool, Python. R is also there. We mostly, if you check in India, we mostly use R in SAS. If you go to the pharma industry, so they use SAS because SAS provides you security to your data because it's a licensed product. But R is an open source. So that's why it is not providing you that much security.